Hello. In this video, I'm going to talk about a different kind of circuit. So we talked about series circuits in a previous video. I'm going to talk about parallel circuits. And there's a big difference between the two. So they're almost like opposite of each other. So in a parallel circuit, so let me just start with one resistor, two resistors, let's say. So let's say I start with a 6 ohms and a 2 ohms. And I put in, let's say, 12-volt battery, just like the previous video. So if I want to find the overall current, I'm going to actually start with the voltages. See, this point here is similar to this point, is similar to this point. They're all connected to the plus of the battery. These X's in blue are all identical. In other words, there is nothing between them. So if the voltage drop here is 12, the voltage drop here, let me do it in green, is 12 volts, and the voltage drop here is 12 volts. So in series circuits, the current remained constant for a set number of resistors. But in here, the voltage stays constant. So that's one first difference. So in the series circuit, the voltage of the battery is the sum of all the voltage drops across each resistor in the circuit. Well, this is different. Okay, now look what's going to happen to the current. The current comes here. So this is your total current. It comes here, it splits. So some of it goes this way, some of it continues this way, and comes down this way. Okay, so if I call this resistor 1, I'll call this current I1. And if I call this resistor 2, I call this current I2. So I total is equal to I1 plus I2. There is a split. We call that the junction rule. So it's just like water flowing from here. And when it comes to this junction, there are two pipes. So some of the water is going to go that way. Some of the water is going to go this way. Now, which resistor is going to allow more current? Well, if the voltage is constant for both of them, okay, the one that's going to have the least resistance should allow more current, common sense, because they have the same push, the same voltage kind of. Okay, so if I want to find the current in the first one, all I have to do is do Ohm's law. Do V equals IR for each branch. So the V here is 12, the R is 2, so I'm going to allow 6 amps to go through here. Now to get the other one, we do the same thing. It's 12 divided by 6, which is 2 amps going through the second resistor. We could have done this with proportions actually. See, this resistor is 3 times this resistor, and the voltage is constant, which means the bigger resistor is going to allow 1/3 of what this resistor allowed. Why? Because this resistor is 3 times as much as that. Now, what happens in the series circuits, we added resistors and we noticed that the current kept going down. The more resistors we add, the more the current goes down. Well, let's see if that's the case. If I add a resistor here, and I'm going to just say maybe this is a 4 ohm resistor, I'll call it resistor 3. What do you think will happen to my total current? Because now my total current is basically 6 and 2, which is 8 amps. Well, I throw in an extra 4. Okay, well, the voltage is the same. Oops. So the voltage is still 12 volts. Well, 12 divided by 4 should give me my current through resistor 3, which is what? 12 divided by 4 is 3 amps. Well, my total current is no longer 8. It's 6 plus 2 plus 3, which is 11. I have 11 amps. Now, if I want to replace this whole circuit with one resistor, what would that value of that resistor be? Very easy. See, you can replace this whole thing with one resistor, and it should look something like that. We don't call it the total resistance because it's not like a real addition. We call it the equivalent. So this is 12 volts, and this current here is 11 amps. You do V equals IR for this setup. So you do 12 equals 11 times R. So R is 12 divided by 11, and you do the math and you'll get some number in there, okay? Let me just take out my calculator, if I can find it. Okay, so I'll use my phone. Okay, so 12 divided by 11 is about 1.09, so 1.10. 1.09 ohms. Okay. Now I'm going to show you another way you can find the equivalent resistance. Then you can find the currents after that. So here what I did is that I found the individual currents, I added them, got the total current, then I drew a simple circuit, and I was able to find the equivalent resistance. Well, there's a formula to find the equivalent resistance. Maybe I'll show you the proof to it in class, maybe not. So to find the equivalent resistance, formula works like this: 1 over Req. The Req is made basically replacing all this, is 1 over R1 plus 1 over R2 plus etc. Well, 1 over Req is equal to 1 over 2 plus 1 over 6 plus 1 over 4. The way you would do that in the calculator, you would not do 1 over 2. You would do 2 negative 1 plus 6 negative 1. The negative 1 button is the one above the x squared plus.
Pardon this late-breaking announcement. Congratulations to the freshman class for winning the 2024 Color War. Your green stripe will be placed on the trophy. Great job to everybody for participating. Have a great weekend.
All right, let me continue. So plus 4 negative 1. Oops, I did something else. 4 negative 1. And once.
Pardon the second interruption. I want to thank Ms. Stepner and Ms. Fitzpatrick for an awesome Spirit Week. The spirit here has been absolutely incredible. I looked around the halls 1 minute and it was all decorated. The next, everything was all cleaned up and put away. You guys are fantastic. Hope everyone enjoys this beautiful weekend with your families. Have a great one, everybody. Thank you so much.
Okay, so I did all that. So I found that 1 over Req is 0.916 and change. So now that's 1 over Req, what I found in the color. I have to flip that. So I have to take that number and just click x negative 1, and it should give me exactly 1.09. So now my resistance is 1.09 ohms. Now I can work backwards and get the current. So I can do 12 equals I times the equivalent resistance, and I can find the total current. Well, in series circuits, as we add resistors, the current drops. In parallel circuits, you notice that it was 8 before I added this one. Now it's 11 after I added this one. It's a very simple concept. Think of it like the analogy is like you're in a room, okay, and there is a fire. And if you only have one door to get out, the flow of people getting out is going to be pretty bad. Well, if you have a second door in the back, the flow is going to be better. If you have a third door, the flow is going to be even better. So the current is just about, it's all about how you're going to flow out of in a circuit. And that's it. So thank you, and I'll see you later. Sorry about the interruptions from the announcements.